Alrighty, folks. So today we're talking about section 9.4, our last section in chapter 9. And this is going to be about comparing two population proportions, which remember we call P. Right? So in other words, we're going to be estimating P1 minus P2. Our point estimate, as you probably could guess, is going to be P1 hat minus P2 hat, right? Because P1 hat is the point estimate for P, and P2 hat is for P1, P2 hat is the point estimate for P2. So if we want to subtract P1 from P2, we can subtract their 2 point estimates to get a new point estimate. And of course, our confidence interval is going to look like P hat 1 minus P hat 2, our point estimate, minus E, and our point estimate plus E. All right, same as we have been. Remember, we have some requirements when we're talking about confidence interval for proportion, right? And in this case, we need all of the different versions to work. We need N1 times P1 and N1 times 1 minus P1 to both be greater than 10. And we also need that to be true of the second population. And these should all have hats, sorry. N2 times 1 minus P2 hat also needs to be bigger than 10. And if we have all four of those things being the case, then we can continue on, find this confidence interval. And as always, what we need to know is how to find E. And like in last chapter, when we get to proportions, we're back to our Z table. I'm going to apologize. The Z table we're going to be working with is a little bit dirty. It's got some scratch marks on it, but it'll be fine. And then this should look very familiar because it's just like the one we did last chapter for proportion, right? That's what we had before. We're just going to do it twice and put both of them under the same square root, right? So we're going to do it for both populations, put them both under the same square root, and then multiply that by z sub alpha over 2. So let's get everything all set up here. We're going to move this guy up so we can reference him later. And we're going to move this first problem up so we can work on it. So we can work on it now. And we're going to move this one down so we have enough space to work on the first problem. Okay. So, that should probably be an E there. There we go. So we're apparently looking into what word people would choose to use for soft drinks, either soda or pop. And we want to interpret an 80% confidence interval for the difference between the proportions of people who primarily use the word soda, online or in person. So one of the hints for these things is the true difference generally means the difference in population rather than the difference in sample. So that's one of the things that indicates to us what type of problem it is. So this is a difference in population proportion. And this sentence also tells us that the P that we care about is the one using soda, right? So the P hat for online is going to be the number who use the word soda divided by the total, right? So maybe we ought to figure out the total. Right, so looking at this chart here, right, I sort of kind of already started, right? The online survey, 25 who responded to the online survey use the word soda more than they use the word pop. Right? Now, we're not told exactly how many people filled out the online survey, But if 25 people use soda and 63 use pop, and that's our entire, all the information we have about the online survey, that indicates that 88 people took that online survey. Right? So the p-hat for online is 88. And one of the nice things about this chart form to display data is this tells me that 1 minus p-hat online, that's just going to be the people who didn't choose soda. So it's going to be 63 over 88. I don't even have to do any algebra to figure out what 1 minus p-hat is. Right? So I'm going to go ahead and check as we go. In online, I'm going to start shortening it to OL because I'm tired of writing online. That's going to be 25 over 88 times 88. And that's 25, so that's bigger than 10. And in online times 1 minus p-hat online is going to be 63 over 88 times 88, So that's 63, and that's greater than 10. That's unfortunate. But we'll keep going. So, we're good there. Now, our second survey is this in-person survey. So, let's go ahead and start off finding the number of people who took the in-person survey. Right? We know that 42 of the people who took the in-person survey answered soda, and 12 said pop. So, considering that's the entire bit of the sample that we have information on, that's what we can assume is the entire sample. So the number of people for the in-person is 54. The p-hat for the in-person, again, the ones we care about. Remember, the way we find proportion is the number of people with the property that we care about divided by the number of people total. So since this is asking a question about using the word soda, 42 is the number we care about, and 54 is the total. Right? And we could also do the same quick and easy way to get 1 minus p-hat in person, because that's going to be the number who didn't choose soda, and for our information, all that is those 12. So again, we could have gotten that by doing that subtraction and doing some algebra, but we can also just get it by looking at our chart. It's the nice thing about that kind of chart. So the in-person in times the in-person proportion is going to be 54 times 42 over 54, which is 42, which is bigger than 10. And 1 minus the proportion in person is going to be 54 times 12 over 54. 54's cancel again. That's 12. That's still bigger than 10. So, we have verified that we can use this method. So, we just need to figure out what E is. So, E is going to be Z sub alpha over 2 times the square root of p-hat online, 1 minus p-hat, or this is in person rather. Right? And it doesn't matter what order we do it in, as long as we do both and we match everything up. So that's what our formula is going to look like. Z sub alpha over 2. We have an 80% confidence interval. So C equals 80%. So alpha must be 0.2. So we need to find that Z sub alpha over 2. So we find, well, our confidence interval 80 here. Our confidence interval is 80 here. That matches up with our alpha of 0.2. So we know that the z we're looking for is 1.28 times the square root 25 over 88 times 63 over 88 divided by 88 plus, oops, those are the online numbers, but like I said, it doesn't matter which is which as long as they all match up. Those are all online numbers, so we're fine. So the in-person ones, and I take the square root of that whole thing. So plugging that into a calculator, we get 1.28 times the square root of 25 times 63. 25 over 88 times 63 over 88 divided by 88. And all right. And make sure I got all my parentheses in the right place for that piece. Then we want to add to that, still inside the square root, our other fractions. 42 over 54 times 12 over 54 divided by 54. Alrighty. I think I plugged it. These are tricky to plug in to my calculator. It helps when I don't have leftover junk. Okay. So this is 0.095, right? And that's the right type of number that we're looking for. Remember, these errors, we should consider them as errors of percentages, right? So numbers that look like 0.095 are exactly the type of numbers that we might be expecting, right? So this is going to be p hat, let's do online first, and then in person minus e, and it's going to be p hat online. Again, it doesn't really matter what order we do this in as long as we pay attention and do it the same in both places, and then pay attention when we're interpreting. So this is going to be 25 over 88 minus 42 over 54 minus 0.095. That's going to be 25 over 88 minus 42 over 54 plus 0.095. Now this, I'm not even going to try to do in my head. I'm going to throw it into my calculator. Because I'm not going to do that sort of crazy conversion. So this is negative 0.58887 and negative 0.3987 roughly, right? So what we got here, what we have here are two negative numbers, right? So remember, if we get two negative numbers, that means that we have subtracted the bigger one, right? So that tells us that the one that came in second here is the one that's bigger. So we are, what was our percentage? 80? We are 80% confident that more people proportionally use soda in person, right? Or that the proportion of people who use soda is bigger in an in-person environment than an online environment, right? But the main thing is where the proportion of people who use soda and are in person is going to be the larger one because both of these numbers are negative. Excuse me. All right. So next one, we don't have a table, so we'll have to figure out our information from what we have here. So we have a survey that was given at 2 different points in time. And it's asking about a confidence level, or whether or not they were confident, really. It probably is probably not how confident. If the answers were going to give us a proportion, it was, are you confident or are you not confident, right? That was part of the requirement for these, the setup of these problems is that, like a binomial distribution, there's a yes or no answer. There's an either or option. So we have 2 different. We have August, which I am going to shorten, and we have February, which I'm also going to shorten, but I'm going to have it at least the full way once. So 200 students responded in August, and 300 responded in February. So the final question asks who feels confident. So that tells me that the p-hat for August was 0.72, right? Because 72% said they were confident, right? And the p-hat for February is 63%, right? Because 63 of the ones who responded in February said they were confident. And feeling confident is the measure that we are testing here. So some things that are often nice to figure out, we can go ahead and figure out 1 minus p-hat of August. That's just going to be whatever's left over here. So 73%, the rest of it is 28%. Right? And 1 minus p-hat for February is, again, 63%. So the opposite, or the rest of that, is going to be 37%. We also want to know what alpha is. And this is one of those that gives us alpha directly. So alpha is 0.05, which tells me that my confidence level is going to be 95%. So that's a good thing to keep in mind. And that's all we need here. All right, again, so there are commands for doing this on a calculator. This one is, in particular, a little bit tricky because the calculator doesn't understand that you're doing proportions, so you have to give things different names. But again, the book talks about how to put it into a calculator and has some screenshots there. So it's going to do better than I can. But this is still the sort of stuff that you need. We're going to use the formula, however. So the formula is E is Z alpha over 2. Just checking to make sure good. Times the square root of p-hat August, 1 minus p-hat August, all over n August, plus p-hat February, 1 minus p-hat February, all over in February. So this is going to be z sub alpha over 2 is z sub 0.025. This is a square root 0.72 times 0.28 all over 200 plus 0.63 times 0.37 all over 300. Z alpha over 2, we're looking at a confidence level of 95, alpha of 0.05, so we go up to our chart. That one was apparently one we tried to find last time we used this table. So we get 1.96 again. So 1.96 times the square root 0.72 . Alright, now we're going to throw that into our calculator. 1.96 times the square root of 0.72 times 0.28 divided by 200 plus 0.63 times 0.37 divided by 300, and we search for that, we get roughly 0.083. Alrighty, so that's our E. Let's go ahead and find that point estimate. We didn't do it last time just because I wanted to show different ways. So let's say our point estimate is P August minus P February. Right, so that's going to be 0.72 minus 0.63, which is 0.09. Oops. So our confidence interval is going to be our point estimate minus E, and our point estimate plus E. So we get 0.09 minus 0.083, and we get 0.09 plus 0.083. So this is going to be 0.007 and 0.173. Right, so we can look at this and we notice that both of them are positive. So let's see, we're at a 95% confidence level. We are 95% confident that proportionally more people had confidence in the college president and so being it's positive, it means that the first one in the subtraction is the bigger one. So the first one in the subtraction here is associated with August. So, right. But we can also take from this, we can take some nuance from this, right? This is really, really close to 0, right? It's always going to be positive, but it got really close to 0. So, it is not, while they had more people had confidence in August, probably, or it wasn't necessarily that much more proportionally. So we can always, right, we have our three big categories of both negative, both positive, or one negative and one positive. But we can take some nuance from there to consider how close do they get to 0, right? Because that's the big question, right? Is it bigger than 0? Is it less than 0? Or is 0 in the middle? And so when it's close to 0, that can also tell us some things about our question, right? So that wraps up the chapter for us. Next chapter is all about hypothesis testing. So we're going to talk about a couple of different things that we can test with hypothesis testing. Mostly it's the same thing we can do with confidence intervals, right? These are actually two different methods that you can use to analyze the same sorts of problems, and they have their own strengths and weakness. And we'll talk more about that next time.